Hello everyone, today our team, me, Mar and Masad, presented by machine learning method called random forest. It is one of the most powerful and frequently used algorithm for solving problem and the classification and regression problems. We analyze the basic principles of its operation, its features, and understand why it has become so popular in the field of machine learning. And let's start with a brief introduction. Random forest is an ensemble machine learning method that combines multiple decision trees to solve classification and regression problems. The basic idea is to create several decision trees, each of which trained on random subset of data, and then combine their prediction to obtain the final result. This method helps to reduce the disadvantages of single trees and significantly improve the overall accuracy of the model. The main features of the algorithm. The four main features: it's the rise of the use of ensemble of decision tree, bagging, averaging and voting, and working with missing values. It's first of all, it's a use of ensemble of decision tree. A random forest combines several decision trees, which makes the model more stable and accurate than single trees. In the bagging is a random subsample of data is created for each trees with replacement. This reduces the likelihood overfitting and makes the model less sensitive to change in the data. The next one is the averaging and voting. It's a regression task. The model average tree prediction, and the classification task selects the most frequent class. This reduces variance, improves accuracy. Variance improves accuracy. Working with the missing value. The random forest can efficiently handle missing values, which simplification in data preparation and the reduced information loss. The next slide, why the random forest is popular in machine learning. First of all, it's a high accuracy. It's a random forest always to achieve high levels to accuracy and the predictive ability, the resistance to overfitting. By using an ensemble of trees and random sampling of features, random forest reduces the likelihood of overfitting, which is a problem single decision trees. And the last one is flexible in application, suitable for solving various tasks of both classification and the regression model.
What is decision tree? A decision tree is a model that divides data into subsets based on questions based on data attributes. The structure includes the root nodes, branches, internal nodes, and leaves. Each node represents a condition or question. The branches lead to different outcomes, and leaving contain prediction, classification, prediction of categories, for example, spam or not spam. Regression, prediction of numerical values, for example, cost prediction. There are three essential concepts of random forest, which are the essence of ensemble method, bagging bootstrap aggregation, averaging the results. The essence of ensemble method means single decision trees may be prone to overfitting, but combining their results into an ensemble helps to improve the accuracy and stability of the model. Bootstrapping: for each decision tree in the forest, a subset of data is randomly selected with replacement. This is called bootstrapping. This reduces the correlation between trees and makes the model more stable. Averaging the results: for regression problems, the results of all trees are averaged. For classification tasks, trees are voted on and the most frequent class is selected. This reduces variance and errors.
So in this slide, I will teach you how random forest works. So a random forest is a random subsamples of data are created for each tree. At each step of feature selection, a random subset of features is selected to split in the tree nodes. I can give you an example. That is, you can imagine a tree. There are many branches, and every branch has many other separated nodes, or we can call it subset. Hope you understand. These are 4 advantages of random forest. For the first one is resistance to retraining. The second one is working with large dataset. The third one is processing the missing value, and the last one is low correlation between trees. So as we can see, the advantage is mostly that we can easily handle the missing value and easy to find the data sets. We can easily to understand, and it's very resistant for training, so we can easily learn and produce the random forest. So these are an example of application of random forest. We give you 3 examples in medicine aspects, finance aspects, and bioinformatics aspects. So for the medicine aspect, we can predict what kind of disease from a patient based on the patient's data. The second one is finance, that is loan default prediction model. We can easy to analysis using the random forest. And the third one is bioinformatics. We can determination of cancer of someone using a genetic data. As for the conclusion, random forest is a powerful machine learning algorithm that can multiple decision tree to improve the accuracy and the sustainability of the model. The algorithm is suitable for both classification and recognition tasks and can do work with range of datasets. So there are many strengths, and also there are some disadvantage. That is such as the strength is resistance to retraining, the ability to work with missing valuable data, efficiency on large dataset. And the disadvantage we mostly have 2. That is, the random forest model may be less interpolate compared to a single decision tree. And the second one is a large number of trees. The model can take it up a lot of RAM, require large computing resource. So these are the strength and disadvantage. But for the conclusion, random forest is very easy to use. It's very easy to understand, and it's easy in our life journey. So I will leave you with a short video that will make you more understand about random forest. Thank you.
Hey everyone, today we're going to talk about the machine learning algorithm random forest. First, let's demystify what random forest is. It's like having a team of decision trees, a forest if you will, working together to make the best predictions. Each tree votes on the outcome, and the forest combines their wisdom to give us a powerful model. Imagine decision trees as individual experts. A single tree might make mistakes, but when we gather a diverse group of them, our forest, we benefit from their collective knowledge and reduce the chances of error. Now let's dive into an example that illustrates the essence of random forest. Imagine we're predicting whether a passenger survived or not on the Titanic based on features like age, gender, and ticket class. We start with our data, which includes information about passengers on the Titanic. This data includes features like age, gender, ticket class, and the all-important survived outcome. In the context of a random forest algorithm, each question or decision represents one individual decision tree within the ensemble. The culmination of the answers from all of these individual decision trees makes up the random forest. Each tree is like an independent expert making its own prediction based on a subset of the data and a specific set of conditions or questions. Then, when it's time to make a final prediction, the random forest combines the predictions from all of these trees, often by a majority vote, to arrive at a more accurate and robust prediction. This ensemble approach helps reduce overfitting and improves the overall performance of the model, making random forest a powerful tool for various machine learning tasks. We evaluate the random forest performance using metrics like accuracy or confusion matrices to see how well it did in predicting who survived and who didn't. As always, the best way to learn is get a little bit of hands-on practice. You can find the Titanic data set all over, usually on Kaggle or anywhere on Google. So just try out a practice problem and let me know if you have any questions below.